All right. On number 19, this baseball player bunts a .44 kilogram baseball thrown at 43 meters per second. The bat exerts an average force of 6.50 times 10 to the third newtons on the ball for 0.0012 seconds. What is the final speed of the ball? Assuming that the ball is bunted directly back towards the pitcher. Okay, so in this situation, we're talking about a impulse momentum theorem problem. It gives us a force, a mass, one of the speeds, as well as the time of impact. So impulse momentum theorem says impulse, Ft, is equal to mass times the change in velocity. And we want to know a final velocity, or final speed, so we can break this down further and do Ft is equal to m v final minus v initial. So we have 6.50 times 10 to the third newtons as our force. That force was acting for a very short time of 0.00122 seconds. That's going to be equal to the mass. It's already in kilograms, so you don't need to worry about converting it. 0.144 kilograms. V final, that's what we're solving for, minus V initial of 43.0 meters per second. So in this case, we have the ball here headed that way. It's a bat here. And then it's going to bounce back in the other direction. Now remember, momentum is a vector quantity, which means direction matters. And velocity and force are also vector quantities as well. So this was the direction it was originally moving at 43 meters per second. So let's call that the positive direction, which makes this the negative direction. Now, I don't know if anybody ran into this, but as you're doing this problem, you just solved it like this. You solved for VF. Your answer, 1, would not have been negative, and we would expect it to be negative. And 2, if you checked in the book, wouldn't be the right answer, period. Wouldn't have the right magnitude of an answer. So, what are we missing here that will help us get this to come out to be a negative velocity? As you can expect, the velocity changed direction, so it should be negative. But if we solve this the way it is written, it won't come out to be negative. What's happening? What's missing? Now, is mass a vector quantity or a scalar quantity? It's a scalar quantity. Velocities are both vectors. Okay, but this velocity is positive, and it is positive. Time is a scalar quantity, so that's not going to be negative. What about force? Is force a vector quantity or a scalar quantity? Vector. And in this case, which direction, with how I have the picture drawn, which direction is the force going to be acting? In the positive direction or in the negative direction? In the negative direction. So our force should be negative as well. So negative 6.50 times 10 to the third. Because we're going from positive velocity to negative velocity, that's swinging that way, so that force obviously has to be going in the negative direction as well. So to get the right answer, we need to make sure we recognize that and make it negative. Okay, so then from there, we can solve for V final and divide both sides by 0.14 kilograms, then add 43 to both sides. When we do that and our algebra is done, we get V final is, I think it comes out to be 12.1 meters per second, or negative 12.1 meters per second. The question actually asks for speed, so that's its final velocity. The final speed would just be 12.1 meters per second. Speed need not include direction. So that's how we do that one.